Let us look out at the analytical treatment of the formation of standing waves. Standing wave is formed when two progressive wave trends, one incident and another, reflected superimpose on each other. It should be borne in mind that the reflection of a wave from a denser medium leads to the phase difference of pi without change in the type of the wave, and from a rarer medium it leads to the phase difference of zero. A phase difference of pi means a compression is reflected as compression, or a crust is reflected as crust. A phase difference of zero means a compression is reflected as rarefaction and a crust is reflected as trough. So it should be clear that in the formation of standing waves, the incident and the reflected wave have a phase difference of pi or 180 degrees. Now, as we have already discussed in the previous lecture how standing waves are formed, we have discussed the formation of the standing waves by graphical method. We know that how standing waves are formed. That means here we are going to discuss the analytical or the mathematical treatment. So we will take a wave that is traveling in positive x direction and the reflected wave that is traveled in the negative x direction with a phase difference of pi. We will add those waves because those waves will superimpose. We will add those waves and that will lead us to the formation of a standing wave. We will see how standing wave is different from a progressive wave mathematically. So take a closer look. When we take the incident wave that is traveling in positive x direction, that means y1 x comma t is equal to r sine of omega t minus kx. This is a progressive wave that is traveling in positive x direction. Now this wave when it reaches at a fixed end gets reflected by a phase difference of pi degrees. When it gets reflected by a phase difference of pi degrees, it moves in negative x direction. So mathematically it is given as y x2 comma t is equal to r sine of omega t plus kx, minus kx towards positive x direction plus kx towards negative x direction. And in addition, the phase difference here is pi. That means it is plus pi degrees or 180 degrees. We know that sine of theta plus pi is equal to minus sine theta. So we can write it as y2 x comma t is equal to minus r sine of omega t plus kx. Now, these two waves y1 x comma t and y2 x comma t superimpose on each other. When those wave trends, the incident and the reflected one, superimpose on each other, they lead to the formation of the standing or stationary waves. So the stationary wave will be equal to yx comma t is equal to y1 x comma t plus y2 x comma t. That means it will be equal to r sine of omega t minus kx minus r sine of omega t plus kx. Here taking minus r as common. When we take minus r common, yx comma t becomes minus r into sine of omega t plus kx minus sine of omega t minus kx. Simple. Here we will take it as A and we will take it as B. Now this becomes formula sine A minus sine B. We have the formula, trigonometric formula. Sine A minus sine B is equal to twice cos A plus B divided by 2 sine of A minus divided by 2. So here y x comma t, that is superimposed or superposed wave or stationary wave, y x comma t is equal minus r and 2 into a plus b divided by 2. So omega t plus kx plus omega t minus kx. Kx and kx cancels out. It is cos of twice omega t divided by 2 and sine of twice kx divided by 2. Here 2 and 2 goes, here 2 and 2 goes. So the formula of the standing wave yx comma t becomes minus twice r cos of omega t sine of kx. So here we can see that the argument of the cos and sine function is not vt plus minus kx, which is an argument of the cos or sine function in the progressive wave. That means the standing wave or the stationary wave is not a progressive wave. So it is different. That means it does not progress in the medium. There is no transfer of energy in the medium. This stationary or standing wave remains confined between the two fixed ends of the string. Its equation is mathematically different from that of the progressive wave, whose argument of the sine or the cos or the trigonometric function has got the value of v2 plus minus kx. The equation of a progressive wave yx comma t is minus twice or sine kx cos of omega t. This minus 2 or sine of kx is the amplitude of the standing wave. So this amplitude depends upon the value of x, so it is different for different points. In a progressive wave, the amplitude is constant for a point. So here we see that a string is fixed between the two ends. We know that if its length is equal to L, at x is equal to 0, at one end at x is equal to 0, the amplitude is equal to 0, so it is a node. At the other end, when x is equal to L, the displacement or the amplitude is also equal to 0. So at two fixed ends of a string, there is always a node. That means the displacement at the fixed ends is equal to 0. So we can see that here y x comma t is equal to 0 for x is equal to 0, because sine of kx is equal to 0, sine 0 is equal to 0, this whole term becomes equal to 0. So y x comma t is equal to 0. Also we know that y x comma t is equal to 0 for x is equal to L. At the another fixed end of the string, there is a node, the displacement is equal to 0. That means for x is equal to L, y x comma t is equal to 0. That means sine of kl is equal to 0. So sine of kx is equal to 0, while x is equal to L, so it becomes sine of kl is equal to 0. We know that sine of n pi is equal to 0, where n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. So we know that from the knowledge of mathematics that sine of kx is equal to sine of n pi, where n is equal to 0, 1, 2, 3. Now, so kl is equal to n into pi. We know that k is a propagation constant, and propagation constant k is equal to 2 pi divided by lambda. So here 2 pi divided by lambda into L is equal to n pi. Pi and pi goes, so lambda is equal to 2L divided by n, where n can have different values 1, 2, 3, 4, and 5. This is the wavelength lambda, that is equal to 2L divided by n. So this is the analytical treatment of the standing or stationary waves. Thank you.